All right. Hey, everybody. Tyler here. I wanted to show you a project that I'm still working on. It's definitely a work in progress, but I'm at a point where I've hit kind of a creative block. So I wanted to get what I have out there, kind of show how it works. It's at a point at least where people can start playing with it if they want. So I figured we would dive in. And let me just pull it up now and I can show you. It is a 3D-ish engine in Google Sheets using Sparkline. Right now I just have a cube on the screen and I can move around it. I can go up, down, left, right, forward, back, and then I can look as well. Sort of like in a first-person shooter if you're moving your cursor around. So I can move to the left here or to the right. Anyway, yeah, so it does this using a variety of tools that I've made and some math that I've found that I wanted to show. This spreadsheet I'm going to make available, so it's just in the video description and you can copy it and do whatever you like. But I figured I should probably show people how it works instead of just like sending it off into the world. So let me just scroll to the top. We'll start with, I have a bunch of buttons here. That's just these checkboxes down here. And that tells stuff to move or to rotate however I want. I have space for the player, that's you. So for example, like how far to the left or right you are, what your rotation is in degrees. And then I have the camera, which largely doesn't move for a reason that I'll go into in a second, but this is all used for the math that turns 3D points into 2D points so that they can be shown in Sparkline. Down here we have space for objects. So these are the 3D objects that you see in the world. And then below that we have HUD elements, which are 2D objects that sort of stick to the plane of the camera. And those are made using two tools that I have made that I'm also releasing now, because they're basically done, where you can build 3D and 2D objects. We'll start with the 2D one because it's a little bit simpler and the 3D one builds off of it. This is one that I have shown off before, but it allows you to use a grid to draw points on an XY chart, and then Sparkline draws them. So in this case, like you can click here and you add a point, and then Sparkline draws a line from the previous point to the new point. And you can undo and reset and all of that. So here I've drawn just a little heart, very cute. And that gives me coordinates that I can now copy, cut back in here, and paste. And there's always a little bit of white space I found, so I'm just going to remove that. And whoops. I don't think I did it quite right. There we go. There's a little bit more white space. And I'm going to adjust the, like I said, work in progress. There we go. So I'm going to fix this in the spreadsheet before this video goes out, but the last semicolon there should not be there. And then I can make this visible, and now there it is on the screen, and it sticks with the camera as I move around. And I can adjust the offset and stuff, so if I want it to be a little bit to the left, a little bit further, a little bit less than that, we'll say minus 90. Great. So there it is to the left. And if I want to make it smaller, I can adjust the scale. So if I want it to be half as big, I can make it 0.5. And then I got to adjust the offset again. So we'll say 150. Then I want it to go up a bit. So we'll say minus 60. Oh, nope. Positive, sorry. And a little bit less. Great. So like, for example, if I wanted to have a health system in a 3D game, I could draw a little heart there that just sticks wherever the camera is looking. And you can adjust whether stuff is visible whenever you want. Let's go ahead and make that invisible for now because that's going to make things messy. For 3D objects, I made a separate sheet that's pretty similar that does the XY grid, or in this case XZ, for a reason, again, I'll get into when I explain how we're converting stuff into 2D. But you can pick the height of where the dot is, and that's the y coordinate in this case. So for example, here I've drawn a little pyramid using points at all four corners at a height of 1, that's this bar here, and then 1 point in the middle at a height of 64. And I've made it so that when you select the height, all the points that are at that height are highlighted darker, and all the points that are at different heights are gray. So you can see kind of where stuff is horizontally, and then know that you're at the right level vertically. And then this does the same thing, where I grab coordinates x, y, and z. I can come in here, paste them in, make sure to get rid of that last semicolon. And I did not get rid of all the white space. There we go. So that's the object coordinates, and now I can set its origin. There's a couple different origins here. The global origin is where it is in the world. In this case, 0, 0 is considered to be, if you picture like a 2D map, 0, 0 would be the bottom, now I have to think about it, the bottom left, there it is, with positive z going up and positive x going to the right. So for example, if I wanted to put this very far away and to the right, I would say 100. If I want it to have the same height as the player, like if I want it to be on the ground, I would give it a y of 0 and then an x of 100. In fact, I'm going to say actually 200 here, or a z of 100 rather, so that it's a little bit further away than this cube we already have in here. The local origin is what is the center of the object itself. This is used for rotations primarily. So for now, I'm going to say that it is the exact middle of the object, and I know that it is 32 by 32 by 32 because the object builder only goes up to 64, because I felt like bigger than that would be an unreasonable spreadsheet to look at. So I know that the object itself is 64 by 64 by 64, so I just pick a point in the middle, and I want it to be rotated around its y-axis. There we go. I want it to be rotated left to right 45 degrees, let's say. And you'll notice there's a bunch of math happening here. So now we get into a little bit of why things are laid out in the way they are. Because of how 3D plane mapping works, what you're doing is you're saying, okay, there is an image plane, a camera in front of where the player is. When you hold a camera up to your face, your eye is looking at a flat thing that is showing you 3D objects. So you're sort of taking in light, laying it flat, and then putting it into your eye. And that's what we're doing here. The trick with that is when you start rotating and moving that camera around, there's a lot of there's a lot of more complex math than I want to deal with. So what we're actually doing is we're leaving the camera where it is, and we're moving everything else around it. This is like a geocentric view of 3D. So what we do is a bunch of math to the objects themselves so that they can then be projected into the frame. The first we do is local rotation, so that's rotating it around, again, that y-axis. Then we adjust to the global origin, so we've rotated the object, now we move it to where it belongs, and then we adjust for where the player is in the world. So as you hit up, down, left, right, you're actually moving all of the objects around the player and not the player. Then we do global rotation. That's for when the player moves around. We're actually rotating the objects on at the X, Y, and Z planes. And then there's two global rotations because it was just easier to do that way. So the first one is around the X and Y coordinates, and then the X and Z coordinates, again, for a reason. And then the second is around the Y coordinate, so that we're looking up, down. So anyway, so it's a bunch of math that's in there. This is probably the simpler math that we're doing. You can look at it if you like. I've used the number formula to sort of add in some notes here so you can see which math is for X, which math is for Y, which math is for Z. And we're doing math to all the coordinates from our object builder to get something that can be displayed. Same for this. What we're doing is for our 2D elements, we're adjusting them to our screen size. And then, of course, using the offset and the scale. That math is a little bit easier. You can just see it all right there. It's a one-liner, as they say. And then what we're going to do is we're going to make 3 big calculations to figure out what cells, or rather what points are where. And you can even see here, I've dropped in that object and it is already visible in the plane. In fact, I'm going to hit reset here and you can see there it is further back behind the cube. Oh, and this is a nice little bonus. I was wrong earlier. 0, 0 is the bottom right of our sort of 2D map. So as I give positive numbers, things are going to go to the left, and that is because of how we are projecting points. Which is, first we grab all of the points from all of our 3D objects, and we join them all together. And is this where we are filtering? Yes, so here we are using a query to filter out those where the third column, the Z column, which is how far they are from the camera, where we're only pulling points where that is greater than or equal to 1. Because anything less than or equal to 1, again, because 1 and 0 is kind of where our camera is, anything less than that number is technically behind the player, and we don't want to worry about it. So we're cutting down on how many points we need to worry about by getting rid of everything that's behind the camera. And that's that first cell. And then we're adjusting things for the camera. Now this is where I'm going to admit I do not fully understand the math. So what I did was, when I wanted to see if this was possible, I pulled up literally the Wikipedia page on 3D projection. I found the mathematical formula, and I used this bunch of formula here, and I wrote out, and you can see them here, these little n formulas. I wrote out effectively the variable names for each variable in the equation, and then one by one I went through and said, okay, x, what is that? Well, that corresponds to this cell over here. So then I plugged in that cell, and I just went cell by cell to figure out, okay, what am I dealing with here? And then it worked. And that's kind of the benefit of like finding formulas, is somebody else has done the work for you. So you don't necessarily have to understand what the math is. It just works, which is great. So that's what that's doing, is it's adjusting all the 3D points using this formula that I've linked to into 2D points. And the reason, and I said I would explain this, the reason that we have our object builder as the X is horizontal and Z is the vertical here on our 2D plane, is that's how this formula works, is it assumes that X and Y are the X and Y on the camera plane, on the viewing plane, where X is horizontal and Y is vertical. And then Z, the third dimension, is distance from the camera. So that's why it's a little bit different than what you might be used to in other 3D engines, where X and Y are horizontal and vertical on the 2D plane, and then Z is the distance from the bottom of that plane. For example, if you're in Unity, that might be what you're used to. Okay, and then the final thing is we grab all of our 2D objects, all of our HUD objects, and we drop those straight on top of our adjusted 3D points, and then we condense everything into our 2D plane. This is a little bit of extra math that, again, is in that 3D projection wiki page. And then what we do is we just have a very simple Sparkline formula that's grabbing all the displayed points, our X and Y, and saying, all right, give us all of them, and then put them in a frame that is based on our aspect ratio. So right now I have it in a 16:9 aspect ratio because that's what I like the best. But you could adjust this to a 1:1 aspect ratio if you wanted for some reason. You would just have to then change the shape of the cell to be a square. Or you can do like 3 by 4, for example, and you can see stuff sort of shift and change. Let's change it back to 16 by 9. There we go. Yeah, so really what it's doing is we actually have a viewing plane that is from, well, in this case, negative 1.6 to positive 1.6 on the horizontal, and then negative 0.9 to positive 0.9 on the vertical, because that's sort of the range that these formulas put our points into. Yeah, and then, like I said, as you play with the buttons, really what you're doing is just moving this math around, not necessarily the player. You're changing where the objects are moved to so that then they can be displayed with that math that I've just done a plug and play on them. And that's where it is right now. There's a lot that I would like to do with this, but like I said, I've kind of hit a little bit of a creative block, I guess. Primarily what I'd like to do is, here, I'll rotate it so you can see it maybe a little bit better. As you move through the world, you'll notice that because Sparkline wants to do everything in one line, there's a line that connects all the objects, and that is going from this corner of the cube here to the corner of the pyramid. For the most part, that's okay, especially if you keep the first and last point in each object at the bottom, whatever that is. But especially when you start mixing in HUD elements, like say, let me drop this heart back in, then it gets a little messy, right? Because then you've got the point going from the heart to the cube to the pyramid and then to whatever else you want. And let me just get that pyramid out of the camera. Yeah, stuff gets weird as it goes off frame. So what I'm looking for is a way to either have each object draw its sort of connecting line to somewhere off screen first so that you can sort of see lines going to each object from the outside to create sort of like a pseudo perspective thing going on. Or I don't know what, find a way to figure out a better order to draw objects in maybe so that like the lines aren't crisscrossing. The other thing that I really like to try and figure out is opacity. This is one of those things that I was thinking about like in the shower one day. But for example, if I wanted to make this cube opaque rather than being able to see all the lines in it, it's technically possible to calculate, well, okay, here's a opaque shape, for example. Like say you took all the opaque objects and converted them to 2D first, you could say, well, this shape here you can't see through and this shape here you can't see through, so don't draw any points that are behind it. So you could, in theory, make these 2 points go away, or at least like not draw them until you need to, right? But the trick with that is that if this point is connected to this point first, and then here, and then here, and then here, the drawing might get skewed because of the order in which the points are arranged. It might, for example, draw from, from this point to here, and then up to this corner, because that's like the next one in the range for whatever reason, and then over to here, and then down. So it's kind of a moot point. So again, kind of figuring out a way to order the points in an order that makes sense for making stuff opaque. You can maybe see why I'm at a bit of a halting point with that. The next thing that I want to figure out before that, though, is collision. Right now, you can kind of just walk through objects, and it's fine. I would love to be able to figure out how to calculate collision with solid objects. I think that's going to be just a matter of drawing an imaginary bounding box around most objects and just assuming that like everything has a rectangle of a certain size around it. But it'd be really cool if I could make that a little bit more complex. So for example, if I had a concave object, I could walk into the concave bit, but not through it. So yeah, so that's where it's at the moment. I hope that this is useful to somebody. We'll kind of see where it goes. I'm gonna take a little bit of like a break from it to think about it for a while, but I wanted to get this out there. Um, yeah, yeah. So if you have questions, let me know. That's my Twitter handle thing on the video. Um, and I'll put a link to everything in the notes. So, thanks everybody for watching, and I hope you have a good rest of your day. Bye.